All right, so we're going to get started with proportional versus non-proportional relationships. They're very easy. I'm going to try to make this as simple as possible. So a proportional relationship is a relationship where your unit rates, also known as a constant of proportionality, remain the same in between every x and y, okay? Remember, an x and a y will help you. It's a coordinate. It's going to help you decide what's independent and what's dependent based on your units, guys. So in order for it to be proportional, when you divide your dependent variable by your independent variable, it must remain constant for every ordered pair. It must remain constant in order for your relationship to be proportional. So let's just go ahead and talk about this. We already know that independent variable is x. It's the thing that happens first. Your dependent variable is your y, so it's the other thing. All right, so I want to see if this is going to be a proportional relationship, whatever it's talking about in one. So let's read it. Alberto types 45 words per minute. So I have two units. One is words, the other one is minutes. Now I'm going to talk about which one is independent and which one is dependent. You all know before you can type a word, some time must go by. So time must happen first. That is our independent variable. Therefore, this one is our y, or our dependent variable. It goes on to ask, is the relationship between number of words and the number of minutes, is it proportional? Why or why not? So let's take a look at this table. I know that in this table that time must go by first, minutes has to be x, and words has to be y. So I'm going to label it as x and y in the table. Now, I said in order for it to be proportional, that when you divide your dependent by your independent variable, it must remain constant. Dividing your dependent by your independent variable just simply gives you your unit rate. Your unit rate is equal to your dependent variable divided by your independent variable, or we can say it's equal to y divided by x, guys. Your unit rate can be found by taking your y divided by x. All right, so what we're going to do is we're going to take each y and divide it by each x. So the first y in this table is 45. I'm going to divide it by its x, its corresponding x, which is 1. And 45 divided by 1 is 45. Now 45 refers to words, and 1 refers to minutes. So basically, it's 45 words per minute. Now, if this table is proportional, I will continue to get 45 words per minute. So the second y is 90, and the second x, the corresponding x for it is 2. Well, if you take 90 and divide it by 2, and you can use your calculator to check along with me, 90 divided by 2, I'm going to pull mine up and work it because that way I know you have time to work it as well. Get your calculator out and do 90 divided by 2, and we get 45 as well. So that's also 45 words per minute. Okay? Now let's take the second y, the second dependent one, which is 135 words, and divide it by the corresponding x, which is 3. So using your calculator, punch in 135, then divide it by 3, and we also get 45. So far I'm getting 45, 45, 45. If I continue to get 45 all the way throughout, I'm going to say it's proportional, okay? Because it's remaining constant. Anything that has a constant rate of change is said to be proportional, okay? Okay, let's take the fourth y. The fourth y here is 180, and divided by its corresponding x, which is 4. So if you use your calculator, 180 divided by 4 is 45. So I'm getting 45 again. I just got to check one more, see if I get 45. Okay, let's take that last y and divide it by its corresponding x, which is 5. 225 divided by 5 is also 45. Okay. So I see I get a constant rate. That constant rate is known as your unit rate here. That unit rate is 45 and it's 45 words per minute. And because it's constant, I can say that yes, it is proportional. Okay? It's proportional because I constantly get 45. Now, if you find a table of values or you find a relationship that is proportional, you can write an equation for these things. I can write an equation for this table of values. Equations for any proportional relationship can be written in this form, guys. Y equals to kx. Now, what does all this mean? So you all should know that y is your dependent variable. Okay? X is your independent variable. And K, it tells you right here, K is your unit rate. A unit rate is also sometimes called a constant of proportionality. So I'm just going to say this is my unit rate. K is my unit rate, okay? So I'm going to write an equation for this problem. What was my unit rate for this problem? My unit rate was 45. So instead of saying my unit rate, I don't have to write those words out all the time. I can now say my unit rate is represented by the variable K. So I can say K is 45. So looking at the equation, the form, if I know K is 45, K is always attached to X, or my independent variable. Okay, so now I'm just going to keep X and Y, and I'm just going to attach 45 to X. So it's basically like this, guys. K is 45, and I'm going to replace, all I'm going to do is write this form down because this is the form for proportional equations. I'm just going to replace this value of K with 45. Everything else stays put. So the equation for that table is Y equals to 45X. That's it, I'm done. And that 45 just means 45 words per minute. So you can find the equation to any proportional relationship by taking your unit rate and attaching it to your independent variable. Your dependent variable will always be on one side of the equal sign by itself. All right, let's take a look at number 2. All right, if you take a look at number 2, it says the table shows the distance Allison drove on the day of her vacation. Is the relationship between distance and time proportional? So I just figure out which one is X and which one is Y. Well, time has to go by first before you can drive any distance. So time is your independent variable. So time down here is in terms of hours. I'm going to put that as X. And distance is your dependent variable. And your dependent is going to be labeled as Y. So miles is Y. Hours have to go by before you can drive any miles, okay? So you can't go anywhere without time passing. All right, so I'm going to see if I get a constant rate. Let's see. If we do, it's proportional, guys. So I'm just going to find my unit rate for each one of these. I'm going to find your unit rate, take your Y or your dependent variable and divide it by your independent variable, or Y divided by X, okay? So the first Y here is 65, so 65 miles divided by 1 hour means that Allison drove that first hour at a speed of 65 miles per hour. Okay. The next Y is 120, so that's 120 miles. She went 120 miles in the course of 2 hours. So if I divide to get the unit rate, that's 60 miles per hour. Well, I can already tell you this is not proportional. I'm not going to try to find any more unit rates. It's not proportional because it's not a constant rate. Okay, it's not the same. That's 65 miles per hour. Here she drove 60 miles per hour. Might have been because of traffic. Traffic might have got heavy. So she might have had to slow down, okay? Definitely not proportional. Since it's not proportional, I'm not going to worry about writing an equation. If I write an equation of something proportional, it'll be like that. This represents something proportional. Something that's not proportional would be something like this. It'll have something added to it or something subtracted from it. If it's like that, it's not proportional. If you ever see an equation that asks you which equation is proportional. The proportional equations are written in this form. They just have some unit rate attached to your independent variable. But if it's got something added to it or subtracted from it, it's definitely not proportional, okay? And let's take a look at 4. Which situation represents a proportional relationship between hours worked and amount earned for Matt and Jane? So hours, you got to put in some hours before you get any earnings. Nobody's going to pay you and you haven't worked. So this is the first thing that happens. So it's our independent variable. So I'm going to go to my tables and find hours and label it as X. Both of these are X's. Therefore, the amount earned has to be Y, or it's my dependent variable. So go to my tables and label these as Y. It says which person, Matt or Jane, has a constant rate of pay. In other words, which one is proportional? Because if they have a constant rate of pay, it's proportional. So let's take a look at Matt's first Y. His first Y is 12, so he got paid $12 for the first hour. So that means he made $12 per hour. Okay, let's take a look at the second Y. He made $20 in 2 hours. But you should know that 20 divided by 2 means he went from making $12 an hour to only $10 per hour. So I don't know what kind of job Matt has, but I think Matt has some problems. He needs to talk to his boss, because you can't go from paying me 12 to deciding you're going to pay me 10. I don't think that's right. All right, definitely Matt is not proportional because his rate of pay is not constant. Poor Matt is getting he's getting gypped. They dropped his pay $2. All right, let's take a look at Jane's. Jane's first Y, remember, to find that unit rate, it's Y divided by X. So it's going to be 12 divided by 1. So basically, she got paid $12 per hour right there. And then her second Y is 24. 24 divided by her corresponding X of 2 also gives us $12 per hour. The third Y is 36 divided by the corresponding X. 36 divided by 3 also equals 12. So she was constantly paid $12 for every hour. All right, so it says which person, Matt or Jane, has a constant rate of pay. That would be Jane. And what is it? $12 per hour. That's what she constantly gets paid. I can also say K equals to $12. Or I can write the unit rate equals to $12. Okay? Or you can say the constant of proportionality is $12. All of them mean the same thing, okay? All right, this says write an equation that represents the proportional relationship. Well, the equations for all proportional relationships are written in this form, where you just replace K with whatever it was. K was 12. K is your unit rate. So you're just going to take K out and replace it with the unit rate of 12. So it's Y equals to 12X. And that just means that she makes $12 per hour still. Now, I'm going to say this. Sometimes your independent and dependent variable may not be represented by Y and X. So if they tell you that your earnings are represented by, instead of the letter Y, I'm going to go up here, instead of the letter Y, if you get an ACAP type question, they may tell you that your earnings is represented by the letter P for pay. Okay, I'm going to do D for dollars, guys. D for dollars. And then if they may say, instead of eggs, they may say let hours be H. So you wouldn't write Y equals to 12 eggs. Keep in mind the Y is your dependent. But on this one, they changed your dependent to D. So you write D equals to 12. And instead of X being your independent, here they let H be your independent. So you write D equals to 12 H. This was the independent, but you can change these letters. They don't have to be Y and X. So if I told you that your dependent was D, you would use D over here instead of Y. If I told you that your independent was H, you would use H. You would attach 12 to H. Your unit rate always attaches to the independent variable. Whether they're calling it X or H or whatever, it's always attaching to the thing that happens first. Just remember that. The unit rate will always attach itself to the thing that happens first in an equation. Okay? All right, let's go on and take a look at this. All right, obviously I have two plants because I see plant A and I see plant B. All right, plant A is 18 inches tall after 1 week. I see 2 units. I see inches and weeks. I know some weeks has to go by before the plant can grow. So this is going to be my X. And in a real life problem, they may call that independent variable W. I don't know, but it's what happens first. Just know that the independent thing happens first. So that's independent. And it may be W instead of X if it was a real life problem that the ACAP gave you. And weeks have to go by before your plant can grow. So I'm going to call this one Y, or that's your dependent. Okay. So, and then after it says 36, it's 36 inches tall after 2 weeks. So it's continuing to grow. And it's 56 inches tall after 3 weeks. So I'm going to write this down. It's 18 inches. And I'm going to go ahead and set this up because it's going to ask me which situation represents a proportional relationship between the height and the number of weeks. So I know I'm going to be dividing dependent by independent. I'm going to be dividing the height by the number of weeks. So 18 inches after 1 week would just give me 18 inches a week. And then it was 36 inches after 2 weeks. So that's 36 divided by 2, which is still 18. So far for plant A is constant. And this one was 56 inches after 3 weeks. I'm going to do 56 divided by 3. Take my handy dandy calculator here. 56 divided by 3 is 18.66. Okay, it keeps repeating. That is definitely not constant because this is not proportional. That's not going to cut it. Okay, definitely not. Let's take a look at plant B. Sorry, that's my desk that keeps swelling or squeaking. All right, plant B is 18 inches tall after 1 week. So I still can do 18 because I'm doing height divided by weeks, dependent divided by independent. 18 inches divided by 1 week gives me 18, okay? It's 36 inches tall after 2 weeks. So I'm going to do 36 inches divided by 2 weeks. That still gives me 18 inches per week. So far, so good. And then lastly, it's 54 inches tall after 3 weeks. Let's do 54 inches divided by 3 weeks. 54 divided by 3 is also 18. So plant B is the one that represents the proportional relationship because it constantly grows at plant B constantly grows at 18 inches per week. Inches stands for I. I'm going to put I in for inches. The equation, though, is in the form y equals kx. And I'm going to replace k, where k is, the unit rate is 18. K is just your unit rate. So I'm going to write this as y equals to 18x. The unit rate always attaches itself to the independent variable, or x. All right, let's take a look at 5. The following table shows the amount of candy and price. So I got amount of candy and price. Well, you don't know the price until you bring them the amount of candy. Their amount of candy is in terms of pounds. So they're going to weigh the candy, and then they'll tell me the cost. So I bring my candy, they weigh it. So that has to be the thing that happens first. So that's X. Okay, it happens first. And then this is Y. The cost is Y, guys. So basically, if you take a whole bunch of candy up, and they used to, when I know when I was a little girl, we put it in a bag and we have to weigh it on the scale. And they would determine the number of pounds. And then they would give us a price for that. But you go get your candy first. That's why you do X as your first thing, or your independent variable. And then you pay. All right, so it says determine the constant of proportionality or unit rate. So I'm going to assume that it's proportional then. So I'm just going to check each y divided by x. So that's going to be 5 divided by 2. If you take 5 and divide it by 2, you end up with 2.5. But 5 is dollars, guys. Let me put the symbol in it. 5 is dollars, and 2 is the amount of pounds. So when I divide this, I end up with 2.5, which means you add a zero, make it look like money. That means it's $2.50 per pound. So the candy is $2.50 per pound. Now, if you take the second y, which is 7.50, 7.5, and divide it by the second x, you're still going to get $2.50 per pound. If you take the third y, which is $12.50, and divide it by 5 pounds, you still get $2.50 per pound. So it is proportional. And K is your constant of proportionality, or unit rate. It's $2.50 per pound. And the equation is just written in the form y equals to kx, where K, which is your unit rate, where constant of proportionality, attaches itself to your independent variable. So K is going to attach itself to X. That's the equation. That's all you do. All right. I'm going to put up another video. That video will be discussing how you can tell if a graph is proportional. So that's it for this one. Okay, guys? Thank you.